Hello, in this video we'll talk about statement, symbolic representations. So we start with logic, which is the foundation of reasoning. So here we have multiple definitions of logic. First, foundation of organized and careful method of thinking that characterizes reasoned activity. The study of reasoning, especially concerned with whether something is true or false. That's what we will be dealing with a lot. So formal logic focused on the relationship between statement as opposed to the content of any particular statement. And so some applications of formal logic in computer science is Prolog, which is a programming language based on logic. It is a declarative programming language. So here you do not write what the computer should do line by line like Java or C++. The general idea behind declarative languages such as Prolog is that you decide a situation. And we're also going to cover in last chapter 8 circuit logic. Logic governing computer circuitry. So let's see definition of a statement. So what is a statement? Which is also called sometimes proposition, is a sentence that's either true or false. So for example, a question cannot be a statement. So this example here, all mathematicians wear sandals is a statement. 5 is greater than -2 is a statement. Where do you live is not a statement. And the next two examples of our statement here. Logical methods are used in mathematics to prove theorems and in computer science to prove that the program do what they're supposed to do. So usually letters such as A, B, C, D are used to represent statement. Next we'll be talking about logical connectives. So what are they? So we have the conjunction, which is and the symbol is like upside down V. Disjunction, which is or. Implication, which is if then, and we write A implies B. Equivalence, which is A is equivalent to B, which is basically in other math courses we talk about it as if and only if, meaning if A then B, and also if B then A. If we have this, then we have an equivalent relationship. We're going to try to prove that later. And the negation, which is if you have A as a statement, you negate it with this symbol, A, not A. So statement form or propositional form is an expression made up of statement variables such as A and B and logical connectives, so and or implied and so on. That becomes a statement when actual statements are substituted for the component statement variable. Here is an example. So an example would be A or not A implies B and not C. So here we're gonna see the symbol and, the conjunction symbol and we study it a little bit. What we're gonna do is we're gonna find the truth table for and. So if A and B are statement variable, so for example A can be I want red vehicle, and B I want it to be a truck, this vehicle. So okay, so if someone find me a blue car, so first A, the possibilities of A and B, they both can be true, both can be either true and false. A is false but B is true, A is false and B is false. So that's why I have 4 rows here, because we have 2 statements, and these are all the possibilities for A and B we could have. So when is my statement is true? When did I get what I want? I want a red vehicle, but I want it to be a truck. That means I need a red truck. So if A is true and B is true, that means I got what I want. It's a red truck. I have it. But if, because my complaint is I want both red and a truck. So A true but B false, that will make my statement false. And also A false, so I have a blue vehicle, but it's a truck, but still it's not what we want, red truck. So this is also false and this is also false. So what do we know? When you have and, this is the symbol for and, then in order for it to be true, both have to be true. Otherwise it's false. Now let's look at or. This is or. If A and B are statement variable, the disjunction of A and B is A or B, which read A or B. So again, all my possibilities for the statement A and B gonna be true, 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 false, false, true, and then false, false. So again, if I continue with the same, I need a red vehicle, but I want it to be a truck. So A, red vehicle, B, this vehicle needs to be truck. So if I say I want it either a red or a truck, so when is this statement is true? Either red or a truck. So the only time is not good, or I didn't get what I want, is when both of them is not red and it's not a truck, because I say or. This is the only time it's false. Otherwise, it's true. So let's compare the two. And the only time is true for both of them to be true. It's like you're more demanding. You want this and this and that. So, but for or, the only time is false is when both are false. Otherwise, it's all true. Okay, let's see another connective here, which is implication. This is more interesting. We're gonna take some time to go over this one. So if A and B are statement variable, the symbolic form of A implies B. This may be read A implies B, as you see. Here A is the hypothesis, right? So A is the hypothesis and B kind of conclusion, okay? Note that A implies B is true if A is false, regardless with the truth of B. Let me explain this a little bit. So for example, Miss X passes the exam, then if Miss X passes the exam, then she will get a job. Pass the exam, get a job, all right? So if A is pass the exam and B get a job. So let's see all the possibilities of this situation. So either both pass the exam, get the job, both true, pass the exam, did not get the job, didn't pass the exam, but get the job, and didn't pass the exam, didn't get the job. So as I state here, the statement states that Mrs. X will get a job if a certain condition, passing the exam, is met. So the condition is pass the exam. It says nothing about what will happen if the condition is not met. So if the condition is not met, the truth of the conclusion cannot be determined. The condition statement is therefore considered to be true, or true by default. So what we state in here is that the only time this statement is false is when true leads to false. Like she passed the exam but didn't get the job. Let me put it in a different color so we know. Passed the exam but didn't get the job. This is the only time this an implication is false, because we break the promise here. The only false is when true leads to false. The rest, no promise is broken, and therefore it's true statement. Okay, so this is very important to remember. Our next connective is equivalence. So if A and B are statement variable, the symbolic form A if and only if and only if, which is an equivalent, B, and we write it A equivalent to B. So when is this true? Again, if I have only two statements, A and B, all my possibilities are both true, true, false, false, true, and then false, false. So as we just covered implication, the only time A implies B is false when true leads to false, when the promise is broken. Let me write it again in different colors so we remember that. A true but B false, then false. Again, the same with B implies A. The only time is false when true leads to false. This is true leads to false, which is right here. I wrote them in different color so we know. But the rest we said for implications, they are true. Okay? Now, remember and. For the whole statement to be true, both of them have to be true. So let's see. This is both true. This is both true. But the other two are false. Okay. False here and false here. Now what did we construct? We just did a truth table for equivalent. So what did they say at the beginning? A equivalence to B implies that if A then B, and if B then A. Isn't what I'm saying? This is the same as A equivalent to B. So let's look here. When is this true? In red, right? So it is true when A and B are the same. When A and B are the same. So these are the same and these are the same. So therefore A equivalent to B, and therefore we have true here. Otherwise it's false. So this shows us the equivalence relationship table, but also it tells us that A equivalent to B is the same as if A then B and if B then A. The last connective we're going to mention here is the negation. So it's simple. So if you have A, then the negation of A, if A is true, so A can have two possibilities, either true or false. So not A will be the opposite, false and true. So and an example would be A greater than -2, so the negation for that 5 is less than or equal to -2. She likes butter, so we could negate that as she dislikes butter or she hates butter. She hates butter but likes cream. She hates butter. Every time you have this but, think about it as an and. Or however, it's and. And so the negation would be she likes butter. So as you see, and become for the negation or. We're going to get into this in detail. But so she hates butter but likes cream. The negation would be she likes butter or hates cream. So hence in negation and become or and vice versa.